deionized water to fill our blank cuvette. And the meniscus is there.
And make sure there are no air bubbles, so perfect.
Now we have our second color, so I'm just gonna put this.
The meniscus is touching the line.
Here is our blank. Here is our first color, our second, and then our third.
Okay, it's 800. It's 800 to 200. Use a wipe. Open this. I forgot which direction it goes. Close it up.
It is important to zero the spectrophotometer because it acts as a standard for the other solutions to be compared against, and that will give you accurate absorbency measures.
Okay, so I'm wiping down the two sides of the cuvette. I'll load it in. I'm going to close the lid. And then start. I'm going to name it.
That's about 550.
The lambda max is the point in which the substance absorbs the most amount of light.
Let's take it out. Okay. So take it out. Second.
This is our lambda max, so that's why.
So now I'm taking our blank. I'm going to wipe it down. Excuse me. Wipe it down. But this. And I'll have to close. And then I'm going to press 0. Like you're right. Sorry. I'm actually close that back up. Okay. Now I am taking our next color, just between the two colors. I am wiping it down.
1.5801. 1.5801.
Let's do our last color. Yes. I'll wipe that down.
051. So we're gonna record. Right. And that is our.
Now we just threw away some trash from our lab area, and Nyla is pouring all solutions from the lab into the hazardous waste containers. And then now we're just washing our equipment and wiping down the lab benches.
So the Beer-Lambert law is a principle that relates the absorbance of light to the properties of the material through which the light is traveling. The equation of this is A equals epsilon times B times C. A stands for absorbency, while the epsilon stands for the molar extinction coefficient. And then B is the path length of the sample, which this is usually in centimeters, and C is the concentration of the solution. So this equation indicates that absorbance is directly proportional to both the concentration of the absorbing species and the path length of the sample. And then going to the relationship between absorbance and concentration. So according to the Beer-Lambert law, as the concentration C of a solution increases, the absorbance A also increases linearly.